Hello everyone. Before we start the next session, I just have a public service announcement. We've had the request pass around. If you are not actually using your wireless connection, can you please actually shut it off and just fire it up when you want to connect to the internet. The network is struggling a little bit and we just want to keep it as snappy as possible for those who need to use it. But otherwise, enjoy. This next one we have Ryan Kelly, who's a software developer for Mozilla and has been working in Python for the past 9 years. I've been assured that he's done some very scary things with Python, but today he's going to use his powers for good. Today he's going to teach all of us web developers how to be lazy whilst actually testing our APIs. So please give Ryan a warm welcome and enjoy the talk.
Thank you. So yes, I'm Ryan. I'm going to assume that the applause either means you're all big fans of testing or you're all big fans of laziness. So which of you are the former? Who is here because they love writing tests for their application? Couple, awesome. You guys probably like work out and eat well and stuff as well. Alternately, who's here because they can barely bring themselves to type the words def test into a Python file ever again? I'm actually both of these things, and I suspect many of us are as well, depending on the time of day, the history of the project that we're working on at the time and so forth. And the underlying cause of this kind of duality is best summarised in graph form. This is a very generic graph of the effort that you expend on quality assurance activities versus the resulting quality of your product. So if you're a corporate bean counter, this might be dollars spent on QA resources versus number of user complaints, for example. For a developer, this might be number of tests written versus bugs per line of code, whatever. Your graph is going to look something like this. And when you first start out, down here, if you expend a modest amount of effort, you can receive quite a pleasing and substantial increase in the quality of your application, especially if you're like me and you write bugs with quite some regularity the first time around. The problem is that as you go on and you pick off the low-hanging fruit and you start trying to test the deeper corners of whatever it is you're testing, investing the same amount of effort again produces smaller and smaller increments in the total quality until you get to a point where the effort that you would have to invest to extract any further improvement in your product is not worth the minuscule amount of extra quality that you're going to achieve. And so eventually we reach a natural stopping point. This is classic law of diminishing returns stuff. And we have two options. We could just say, well, this is about as much as I can bring myself to do, or this is about as much as we can afford to do, and we'll accept that that is the resulting level of quality assurance. Or we can put our engineers' hats on and hack this graph, grab a hold of the line and just up there, so that the expenditure of effort is rewarded by a correspondingly greater increase in quality assurance. Now this is process improvement. It might be using tools that let you write more tests quicker, or it might be using tools that let you extract more value from tests that you've already written. But the moral of this talk is really that we should be trying to do more with less in this kind of activity where you're facing these kinds of diminishing returns. Of course, there's no free lunch. I mean, the activity of process improvement is in itself an expenditure of effort. But I don't like to think of it that way. I like to think of it as an investment in laziness. And my view on this is inspired by one of the great classics of modern literature. It's Terry Pratchett's Discworld novel Moving Pictures, in which the male protagonist of the book is described as the laziest person in the history of the world. And he's so dedicated to the minimization of effort required versus benefit gained, that he would do things like go to the gym regularly and keep himself in a state of optimum fitness, because he'd calculated a point at which the effort expended in maintaining his fitness would be recouped in the effort savings in the rest of his life, where he doesn't have to carry around extra kilos, he doesn't have to puff walking up a flight of stairs. I thought, this actually speaks to me about testing and software development in general. So, trying to extract more value from your process is not necessarily work. I like to think of it as an investment in your future laziness. So that's the philosophy of what I want to show in this talk. The nitty-gritty is, as you said, I currently work for Mozilla in the services team, and we basically build web APIs to make your Firefox experience better. Specifically, our kind of flagship product at the moment is the server-side half of Firefox Sync. I'm going to show you the tools and techniques that we use for testing this thing, and basically show you how I try to get them to fit together really well, so that I can achieve maximum laziness in this testing regime, to extract maximum value for the effort that I managed to put in. I'm certainly not an expert in this field, but I will claim to possess two qualities that relate to this talk. I'm passionate about producing quality stuff, but I have a very low tolerance for low-value, high-effort activities. So that's where we're headed. The first tool I want to talk about is WebTest. And if I can start, let me just see. Let's start from a WSGI application, which I assume if you're doing web stuff in Python, at some point you've got a WSGI app. Here's a really silly little example that just is like, hello world. There we go. Now, this is just a Python callable, so I can drive this by hand to implement various testing regimes. But doing it like this, like actually creating a WSGI environment, creating a start response callable, is that's pretty awful. Right? WSGI is a very good interface for machines, not perfect, but it's quite good. It's a terrible interface for humans. So if I can preemptively borrow a phrase from tomorrow's keynote, I like to think of WebTest as WSGI for humans. You get this test app object, you can wrap it around your existing WSGI callable, and then you can interact with it in a much more pleasant way. You can say, oh, well, look, you know, get this URL, and it'll give you back a response, and stuff like that. So basically, this is how we structure, that's not what I want to do, this is how we structure our test cases for the Firefox Sync server. What I've got here is basically an example that I don't want to go through. This is a stripped down, minimalistic version of the Firefox Sync server. We've got some users, they store items in various collections. We've got a method that they can post items into to store them. We've got another method down here where they can get these items back again, and we've got a method down here where they can delete stuff. So this is just some test code that I'm going to use for this talk. What I want to basically do is, rather than trying to go through that, is explain to you how this API works by writing tests for it, with the hope of showing that it's quite a useful activity and quite easy to do. So I've got some preliminaries here. I'm going to type the words unit test into this, like so. Be assured that I'm not writing unit tests, all right? Definitely not. These are like, you could call them functional tests, you could call them integration tests, you could probably argue for days about what to call them, but whatever. I'm going to create a random user ID and their associated URL in the application. And then I'm going to wrap my WSGI application callable in this test app instance. And I'm just going to clear the decks, right? My example application, it has, it's got an on-disk database, so I'm just going to make sure there's no junk in there to interfere with my test. Now, the way this API operates is as follows. I can get a JSON structure of items with some payloads in them, like this. There's some test data. And I can post them into my API at the given URL. I can tell it that it is some JSON data, and that will go ahead and make that request to my WSGI application. I can then make a GET request on that URL, and I can investigate the JSON structure that it returned and make sure that it does in fact contain the right things. So I think this is a really nice balance between expressivity and flexibility. Like, you're still in Python, so you can do things like call out to JSON and you know, do detailed test assertions, but you're talking to your web application like it's a web application, saying post this, get that, blah, 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 blah. So if I run that, I should get a passing test, which is good. There are a lot of helpers in the WebTest API. I'm not going to show you them all, but here's an example. It also has this convenient post-JSON method, which is really good if you're building JSON-based web APIs. So here's a slightly more complicated test. I'm going to post two things in different requests, obviously. I'm going to assert that those things have different modification times because they were posted at different times. And I'm then going to test whether I can query for things that were modified after a particular time. Right? So I hope it's fairly obvious what URLs I'm hitting here, what operations I'm performing on my web API and so forth. Let's flash this out. That little red bar down the bottom of the screen is telling me I'm going too slowly. Anyway, the point I'm trying to make is this is a great language for describing the functionality of your application, for writing specifications about the functionality of their application. Two passing tests. And I can do lots of other interesting things, like if I had authentication in it, I could put in an authorization header and I can tell the test app to use that on all the requests. If I want to make assertions about the return, the response codes of my requests, I can say, well, this request should give you a 404. It's got cookie handling, form handling, all this sorts of fun stuff. Good. So that's kind of my starting point. We have a bunch of functional tests written in WebTest. It's nice and flexible and easy to get going with. And it's very low overhead. Like, you don't have to spin up a server and test against a live server. You're just testing against an in-memory Python application. But because it's all talking WSGI, it opens up some interesting possibilities. For example, WSGIProxy. It's kind of like WSGI server in reverse. Right? Instead of taking a HTTP request and turning it into a call to a Python object, it takes a call to a Python object and turns it into a HTTP request. So if I get into my Python shell again and just grab this proxy app object, I can point it at, say, Google, and then I can drive it in the same way I would drive an in-memory WSGI application, which is not like this because that's too much work and too easy to get wrong. I would wrap it in a test app object, and then I can, it requires me to specify this remote address and I consider that a bug. Then I can just interact, like, so let's search Google for Python and see what's going on. And it'll come back and tell me I've queried the wrong URL. But you get the idea that this very quickly lets you drive a live web application. So the implications are obvious, right? I can take whatever test suite I've just written in WebTest, and I can turn that into a set of live tests to run against my live application. So if I go down to the bottom of my file full of test cases here, I know, I'm going to refactor this thing first. Yeah, I'm really typing this live. No. I'm going to pull this test app creation out into a separate method. All right. So that's just a bit of refactoring there. I'm going to go down to the bottom here. I'm going to add a little if name equals main clause. Yeah. In which I basically use nose and its test runner and WSGIProxy and its ability to talk to live web services to hijack that gigantic suite of functional tests I just wrote and point them all at my live web server. All right? Just take a URL from the command line and point WSGIProxy at it. There we go. Hijacking nose to run these tests for me like so. Ta-da. And if I run that, what do you think will happen? Nothing, because I don't have a server running. Here we go. So if I run that little test server, I can point my test script at it, and I get two passing tests, and you can see it's actually hitting the server that I'm running. So WSGIProxy is really nice. It does one thing, but it does it really, really well. And the thing that it does is really useful, because what I've just created in those handful of lines of code is a deployment testing script, for example. I can point this at my server after every deployment and verify that nothing has gone wrong. And I basically got this thing for free. To give you an example of why this is useful, a couple of months ago we had a security issue in one of our products. And we rushed through a fix and we rushed through a deployment. And we got to the end, and for whatever reason, after the deployment had been done, the server wasn't restarted properly. So the code sitting on the machine had been fixed, but the server that was running actually still had the security vulnerability. Right? So if you have something like this, you can say, oh, well, I'll just run my suite of tests. Of course, it's a security error, so you've written a test to make sure it doesn't happen again. And that will help us to detect that, oh, actually something's gone wrong in this deployment. You can also use this as a really rough and ready load testing framework. Right? Spin up a couple of EC2 instances or something, run a bunch of instances of this script in a tight loop, and you're hammering your server with a bunch of traffic. Fantastic. And if you don't want to invest any more effort, you could probably stop there. You could say, oh, actually, I can run X many copies of this at a time. My server stands up to it. Awesome. But if we're willing to invest just a little bit more in our tools, then we can achieve potentially a lot more quality out of our web app by doing some proper load testing. The tool we use for that is called FunkLoad. And FunkLoad is one of those tools that likes to be everything. Like it's a full stack. You install this tool, you write your tests in this tool, you run this tool against your web app, and it tells you about how it's going to stand up under load, which is fine, but I'm not really interested in another complete tool stack. So I'm going to show you how it works, but as you can imagine, I'm not going to tolerate this for very long. I have a special thing called a FunkLoad test case that I'm going to subclass. And I'm now going to proceed to duplicate that first test that I wrote in WebTest. Yeah, I'm doing this partly because I want to show you the FunkLoad API. Mostly I'm doing it to annoy you. Because it annoys me. FunkLoad is a really good tool for load testing. It's got lots of good features that I'm going to show you in a moment, but in order to use it, I'm supposed to invest completely in it as a separate tool. I've already written pretty much exactly this code, but I now have to duplicate it in a slightly different API. I have to get my target URL from a different place. I have to encode my request body in a slightly different way. I have to call slightly different methods to make a successful request. But the shape of what I'm doing here is exactly the same as what I wrote before. And I'm even making the same set of typos as I did before in putting together this little demo. Okay? So I hope to show you that A, this investment of effort may be worth it, and B, this investment of effort may not be necessary. So let's have a look at what it can do. Thank you. I give it a little configuration file here. I say, here's the URL of the server. Here are some details about how you're going to run the tests, sleeping for various times and whatnot. And here we go. I'll run my little server, which I'm doing on the same machine. And if you're benchmarking something by running a server on machine and running the client on the same machine, you're doing it wrong. But never mind. This is only a demonstration. I can say, run the tests that are found in this file, and it will do pretty much the same thing that I just showed you with WSGIProxy, except that it prints it out in green. So far I haven't gained anything. What the real benefit comes from is when I configure this benching section down here. What I'm going to tell it to do, I'm going to run 4 sets of tests. I'm going to run a test with 10 concurrent users, 15 concurrent users, 20 and 30. I'm going to run each test for 5 seconds because we don't want to sit here all day watching it print little green dots. And it looks something like this. FunkLoad, run the benchmarking suite. Here's the test that I want to run. And it'll chug away and do its thing. So as you can see, it is hammering this poor little single-threaded WSGI ref server with an SQLite database with 10 concurrent users, and to be fair, it is succeeding. If it was failing, it'd be printing little red Fs. Now, I'll let that run so you get a bit of an idea of what it's doing. At the same time, I'll talk about what it's doing. FunkLoad, the idea of using a dedicated tool for benchmarking is pretty important because it solves a lot of problems that you may not have thought of yet. For example, I've asked this thing to run tests with, say, 25 concurrent users. It means you've got to spin up 25 concurrent threads of activity. And you can imagine that there's a period of ramping up where it's running tests with less than the amount of users you've requested, and there's a period of ramping down where the tests are finishing and it's running tests with less than the number of users you've requested. FunkLoad is very careful that it's only measuring things in the period where you've actually got all of the load that you requested. So your measurements aren't going to be skewed by these ramp up and ramp down phases and things like that. Let me see how we go here. Yeah, I'm not sure why that has stopped there. There we go. So what it's doing is basically running all of these calculations, collecting all the measurements, and I'm about to show you how to formulate it all together into a pretty report. Which actually I might skip ahead and show you already when it catches up. There it is. So it's got a little command in there that you can say, look, take this output, generate a nice looking report, and this is the sort of thing you get. So you can see that actually our little single threaded web server didn't do too bad, like it's not falling over. This is the number of successful requests per second is going up as I have more concurrent users. As you can see, the metrics on response time are getting worse and worse because I'm running more concurrent users against a single threaded server. You can get lots of pretty graphs and all these sorts of things. So depending on your setup and what you're trying to achieve, it may or may not be worth your time to learn how to use this tool, to figure out how to generate and interpret these graphs. But what if you could get almost all of that for free from what you'd already written in your WebTest stuff? I don't know what's going on there. Anyway, what I want to do now is, instead of duplicating those tests, I'm going to make FunkLoad consume the tests I've already written. This is a helper class that claims to contain anything, and I'll show you why I need that in a minute. I'm going to grab the tests that I've already written. I'm going to point them at this little utility function here. And instead of going to all of the trouble of duplicating the tests I've already written, I'm going to write a little bit of a conversion script that points the WSGI test API, or basically WSGI, into FunkLoad. So I'm making a WSGI app that when it's called, it figures out where it's supposed to be talking to, it populates the environment with all of these various things, it sets the appropriate headers, it calls out to FunkLoad's testing methods, it tells it that everything is okay. It doesn't have to, it tells FunkLoad not to report failures, because I'm going to do that myself. And basically shuffles that through, grabs the next, grabs the response and sends it back up. So that was slightly more work than just writing the test itself. But I only have to do that once. And you don't have to do that at all, because I've already done it. So not only do I now have the ability to run that test I wrote before without duplicating it, but I also have the ability to run all the other tests that I've written, like this one. And I can incorporate those in a benchmarking suite. I can see how they all behave and so forth. I'm going to skip a little bit this one and go straight to the result. FunkLoad has some cool stuff. One of the nice things that it can do is generate a diff report. So you can say you make a change in your application and you want to say, has this improved my performance, yes or no? You'll get a report that looks something like this. And in this case, I haven't improved my performance, but you can see you've got the top line is your old test, the bottom line is your new test, and the green bits are where it was better, the red bits are where it wasn't better. So by doing a little bit of hackery and fiddling around with your API, you can suddenly get all of this cool stuff from FunkLoad for free. We don't do this in Mozilla yet, but I want to try it out because I think there's got a lot of potential there. The other thing FunkLoad has that's really cool is the ability to run a distributed set of tests really easily. So if I go down into my config file and I configure it, I say, look, these are your dependencies, this is where you get FunkLoad from, and so forth. You can basically say, look, run the bench in distributed mode on the following 2 hosts, and then do the same thing you did before, right? That will shell out to those hosts, it will set up a virtual M with FunkLoad in it, it will install the necessary packages, it will collect the results, it will bring them back onto your local machine, and then you can build those reports out of the resulting files. I'm not going to make you sit through that, but that's pretty cool. And it's really important for benchmarking that you can talk from different machines. So, summing up. These are the tools that we're using at Mozilla, but I don't want to suggest this is like the optimal set of tools you could be using. We started out with some web test-based functional tests. We decided, look, how can we make use of these for other types of testing? You could start alternately from, say, a suite of FunkLoad tests or web unit tests or something like that. And do basically the reverse of what I just did. Instead of trying to go from a WSGI call through to a real call, you can monkey patch the standard library so that your attempts to really call a live web server are redirected to an in-process WSGI app. And I've seen people do this, and they report quite some success. So the real point that I'm trying to make here is, there are good tools out there. A lot of tools look like they do one thing. But can you find opportunities for reuse amongst these tools? And can you get something for free from your tools? Can you use them to leverage the things that you've already done? Aside of thanks, I mean, all of this stuff's not my own brilliant idea. We've got Terexi out on our team, and he's been hacking on this for ages. I think he's currently building like a continuous integration server, but for FunkLoad. So imagine like Jenkins or Travis or something like that. But when you make a commit, it actually queues up a load test of your application and gives you a report and a graph of how the performance of your application has changed over time. That would be awesome to get, and it would be even more awesome to get that for free. James is the head QA guy for Firefox Sync Server, and he basically breaks all my stuff. So thank you to him. I've got the contents of this talk are up online. I've got some links, and basically I've got time for questions.
Just a couple of general FunkLoad questions. Can you give it multiple tests and say, I want to run this test 75% of the time, this one 25%?
As a bench, you can't tell it that directly. So the idea is that you're supposed to only do a single thing and do it lots of times, because otherwise a lot of the metrics don't make sense. Like the number of successful tests per second, for example, doesn't make sense if you're running tests of different durations. But what you can do is write like an umbrella test that then in Python just says, it'll generate some random numbers and randomly pick other methods to call. And that's actually exactly what we do for the sync server. Is basically, 60% of the time do this, 70% of the time do that, various combinations of things. So yes, definitely. But if you're going to do that, the FunkLoad graphs are probably not going to help you. You'll need to depend on like server-side monitoring to see what's breaking or not breaking.
And the other question is sort of related to that. It's providing an external data source to your tests to actually draw, like you mentioned, randomised data, but if you've got a test suite, or a set of test data that you want to push into your web server at load, does it facilitate that?
I'm not sure, to be quite honest.
Cool.
It has certain facilities for doing things like getting credentials from a test credential server and things like that. So, but I imagine it would be pretty easy to add.
Thank you.
Anybody else? I actually had a question. So for the web API that I use at work, we actually, inside, we do HTTP requests to other parts of the API for various reasons. And the way I've done it up until now is basically started a second web server in a different process. Have you got any tips to do that better? Do you do something similar like that at...
Not in the sync server product, but we do have another product that makes HTTP requests internally. I think we basically configure it to mock that out. That's not revolutionary.
Yeah.
It would be interesting to try and put a little redirector in there that goes via WSGIProxy or WSGI intercept. What I showed you before is basically hacks HTTP lib to redirect to another in-process application. I think that would be very cool to try.
Yeah, well, I'm going to try that because when it's in another process, I can't tell what it's doing, so it's really annoying. Anybody else? Nope, no. Last calls? Keith's not in the room? No. Russell, sorry. We've got some, everybody thank.
Cool. Thank you.